Okay, so I want to show you how to get started with using ChEMCAD. First thing you have to do is you must be on the VPN with university. So here's my OpenVPN Connect. You can see that it's working. Once I have that going, then you're going to go online and find Apps Anywhere through MST. So appsanywhere.mst.edu, and you're going to look for ChEMCAD, and you're going to push Launch 8.1. It will bring up the cloud paging, and you may have to say launch a second time. I know I did. Whatever, it's going to now take probably 3 to 8 minutes, depending on your connection, but it is not fast anywhere, even if you're on campus. So you're going to go fix yourself a cup of coffee, and eventually you will get the ChEMCAD screen open. Okay, so that gets you into ChEMCAD. Go get that going and come back, and I'll show you how to do our first little project. Thanks. Okay, so now you have your ChEMCAD up and running, and it's got a big blank screen in there. What I want to do first is let's just explore the general layout of the ChEMCAD screen. Now this is done with version 8.1.1. Most of the tutorials you're going to find are with version 7, and so there's going to be some differences there. But okay, so File is going to give you things like, you know, how to close things out for one simulation. Maybe you want to start a fresh one. This would be where you want to go. This is where you're going to go to print or to send it to somebody. Most of the time we'll start with the home screen. There's going to be select components. We'll be doing this momentarily. Thermodynamic settings is going to be our next important thing. There are other things like changing units. I'll just go ahead and show you that right now. If you choose engineering units, it's going to default to English. If we want to say use metric or something like that, you can choose these things here, and you can also kind of set your own whatever you want. So let's see, I'm going to be doing a problem where I'm going to want some mole entries, so I'm going to choose formal SI, and we'll save that. Okay. Convergence is about tolerances. We're not going to deal with that in this course. If we just want to look at our components, we can come here. Editing our streams or our unit ops is something that we'll be able to do later. This is one way to do it. We'll also find that we can just click on the streamer operation and do the same thing. Mostly run all is going to be what we choose, but we also, when we have a very complex system that we've got in our simulation, we can play with maybe just one unit and run that over and over again to try and optimize that unit without having to worry about the impact on everything else at that time. Now when you run all, that's going to be quite the festival at that point, but that's for another day. We are not using dynamics. Charts is an important one. Charts is going to give you the option of looking at all sorts of various graphs that may be interesting to us. The ones that we're going to be most worried about today are going to be the TPXY for our binary systems, but we also might want to do phase envelopes or stream properties. When we get to heat exchangers, these are some other things that we might want to do. So the charts is going to be an interesting one. Reports is one where you can get it to list out all the data for various streams. We can explore that later. So this is your home screen. If you look at drawing, it's going to give you various options how you might wish to make the simulation look prettier. View will be used when we're wanting to look specifically at a single unit or something like that, or what it looks like. We can change appearances. Thermophysical properties, if we want to get deeper involved in making the model of our vapor-liquid equilibrium system, for instance, better match the data that we're finding, then we may need to get into editing or regressing BIPs, or those binary interaction parameters, or BIPs. Maybe, yeah, so these things here, these are going to be specifically for electrolytes or petroleum mixtures or solids. We won't be getting involved in those. The component database is where you can look and see what chemicals are in there if you're trying to find whether or not your system would be modeled using built-in information, or am I going to need to find more data. Specifications, yeah, we're not really going to be doing that. We're probably not going to get into any analysis or sizing or economics in this course. Tools are how you set up your parameters for those various things. We'll be doing some more with those in your design courses. For the most part, we're going to be sticking to the home. Now down below, there's going to be a list where it's going to give you files that are open. This is going to be our worksheet, and when we create charts will end up here also with various tabs that I can switch between those. And then my palette is over here. This is where I'm going to find my unit operations. And so let's just start by, let's grab a feed stream and we'll bring it over here. And we are ultimately today going to be wanting to do a flash. So let's next grab a flash, and they are alphabetical is the way it's arranged. So you can drag your flash over here. And then I need a couple, ooh dear, okay. I need a couple of product streams, and those are up at the top. So I'm going to have one for vapor and one for liquid. Okay. Not anything very exciting, except for I think it's probably pretty evident that these are not connected yet. So let's connect them. One way to do this is to just simply drag from one where you want it to connect to where you want it to be attached. So I am clicking my mouse when I touch one hot point there, and dragging and then releasing the mouse when I get it connected to the other one. So I now have a feed and two product streams from my flash drum. Well, I haven't selected any components yet, so let's look at that. So select components is on your, it's like the first item, right? It should be yelling at you, do this, this is important. So for this one, let's do ethanol and water. So I can do this by coming down to search and just typing in ethanol, and I find it there and insert that, and now it shows up in my selected components. If I want water as my other stream, so there we have that. If you need to rearrange these, you can just, do that and select one of these and move it up and down. That usually isn't that important. It is going to next come to the thermodynamics, right? Select components and then thermodynamics, and it's going to make suggestions to you. Now I only have two components. If I have a system with a lot of components, it may recommend that I not model certain things using the same technique, but I want to then enter the temperature and pressure range of the process that I'm going to be looking for. Okay, so ethanol and water, I'm going to be looking at things in kind of that near ambient to boiling point, and they have the pressure at basically 1 atmosphere up to a little bit more than that. Okay, and we'll just accept that for now. We're just playing around, so it's fine. What that's going to do is that's going to trigger it to go through a process. It's basically just going through and asking a series of questions. What types of chemicals are these? Do I have electrolytes, or are these all organic compounds? Whatever. Okay. Then it's going to look at whether or not the similarities between the various chemicals that we're talking with. And it's going to make a decision about what type of thermodynamic model we should be using. In this case, and this makes sense because we have the water with our ethanol, it's recommending NRTL, non-random to liquid. It's one that handles somewhat non-ideal mixtures fairly well. And for the enthalpy model, the H, so K's, they're using NRTL, that's going to be my phase equilibrium, and H, that's my enthalpy, and that's going to be a latent energy model is what they're doing there. So I'm going to say okay, and it's going to bring up this screen, which again, even if I had chosen that and then now that I'm changing my mind, I could come in here and choose something else. It's like, oh, I really didn't mean that. I really wanted Ping Robinson. I really wanted whatever, Uniquac. I could come in here and I can make those kinds of choices. But it's starting me with its recommendation. You can go through and look at each of these things, modify them, especially if you have data or if when it does a prediction the model isn't very good. We can look at our enthalpy models here. So this is doing latent heat, how it's getting its sources of the data. I have no issues with any of those. And then the transport properties, it's getting these out of its built-in library. Since these are pretty common chemicals, those should be pretty good. So we'll say okay. And now then it's going to give me this to show me what subtype. So this is going to be good for vapor-liquid equilibrium. It wouldn't be good if I was wanting, say, a liquid-liquid system or something like that. Not what I would be getting here. It's not going to help if I've got solids. All right. But so this is going to tell me what this is going to be good for. I'll just say okay at this point. All right. So I now have components into my simulation and the thermodynamic package has been selected. I have engineering units in here. Let's look at those a little more closely. I would like to have my moles in kilomoles. However, my pressure, I would rather have that be in bar. Okay. Yeah, I'm okay with those other things. All right, I'll apply. All right, so now then, if I click on one of these little labels here, this is stream 1, and if I double click it, it will open up a place where I can edit this. So I'm going to name this the feed. All right, the temperature, well, let me go with a pressure of 1 bar. And a vapor fraction, I will feed in let's go all liquid, saturated liquid. Okay, total flow, let me just come down here. I'm going to do 30% ethanol, and I'm just clicking in these boxes and typing in. Okay. So it's 30 mole percent ethanol, 70 mole percent water. Okay, I did not specify a temperature. Yeah, okay. So it's going to calculate that for me, so I will say okay. Now, this up here, I am going to name my vapor product. This I'm going to name my liquid product. All right, I don't know why that's not showing the feed name in a legible way, but all right, I'm going to click on this stream here, and what I want to do is come over here to charts. I'm going to do the TPXY. So it's going to draw a TXY and a XY diagram for me. All right, my first component I'll list it as ethanol. Second one is water. If I want it all at that constant pressure that I specified of 1 bar, this should be good. Okay. Oh, and you can choose which charts you want here. I'm going to say okay. And it's giving me the graphs. And these do look like they're creating that azeotrope that I expected and at about the correct location. So therefore, I do think that this was a pretty good model choice. We do want to always be sure that we are looking at our data and comparing it to things we know. So we can research this in the literature. Fortunately, our book or on Canvas, we have a lot of literature available. And so I am able to enter all these things. So I'm going to recommend that we pause now. I want you to explore ChemCAD for a moment, and I want you to enter ethanol and water, a mixture. If you want to choose the same thing I did 30% ethanol and 70% water. Right, 30% ethanol, 70% water at 1 bar pressure. Try playing with your engineering units, and then take a break to do that and come back, and then we'll learn how that flash unit works. So now you've looked around, hopefully you've got your stream successfully set up, you've added a flash unit. I had entered 30% ethanol and 70% water at 1 atmosphere here. And so now then I want to open up my flash unit and look at my options here. So they have, I don't even remember how many. Okay, so 10 modes that we can choose. So we can use the inlet and temperature and pressure and then use that to calculate V over F and the heat. Since I had actually not put in a T and a P, I had put in the fact that it was all saturated liquid. I can tell you what my V over F is going to be. It's going to be 0. So that's not probably my best choice for the input I have given. I can specify the V over F, so the fraction I want to be in the vapor phase and the pressure, and calculate T and H. I can specify the temperature and pressure, so forth, okay? I'm going to come down here and choose specify the pressure. I know I brought it in at 1 atmosphere as a saturated liquid, so to get that 2-phase region, I need to drop the pressure, okay? Isentropic means that I'm assuming that it's adiabatic, right? And so if I specify that pressure, let's say I was at 1 bar, so let's make it, I don't know, 0.8 bar. And that's the only thing I have to specify here. Say okay. That doesn't do anything. What you have to do is you have to come back over here to run all, or just run the selected. And so now then it ran, it has not given me any warnings or errors. I have a little green diamond right here. And if I click on these streams, I can see that I have, I think I brought in 100 moles or kilomoles per hour. And so I have 1.336 or 3663 kilomoles per hour in the vapor phase. And I have, 98.6337 kilomoles per hour in the liquid phase. All right. If I analyze, look at this, it will tell me, you know, whatever there is that needs to be specified there. Now, you can play with this, change the conditions. Maybe I wanted to go with 0.6 bar. Okay. Run it again. And again, you can look at your various. And so now then I have a little bit more in the vapor phase, etc. I could also at this point switch that I am going to instead, I'm going to specify V over F and P. So the vapor mole fraction, and let's go with 0.4 for my vapor mole fraction, and my pressure, I'll just take it down to half a bar this time. I'm making numbers up. And let's see if that's okay. And so this time I've got 40 moles of vapor with this composition, and I should have 60 moles in the liquid stream. So you can play with this and do all the various flash calculations. One thing that's interesting to do with this is see what happens if you choose poorly on your thermodynamic models. So this was with NRTL, but what if I did choose something like Pang-Robinson? Pang-Robinson is not going to get that azeotrope. This is the word I've been struggling with all semester. For some reason, it just keeps leaving my head. That's not going to predict the azeotrope for us, okay? And so when you run that one, you're going to get different answers, all right? So you might play with some of these things here, and then if you look in Canvas, there will be another problem for you to try that will be similar. I'm going to give you some different chemicals and have you go through, find the recommended model, verify using data sets that the model is a reasonable prediction of the physical parameters, and then do those flash calculations. Okay, so that's going to conclude this introductory video. Thank you.